Hello, guys. My name is Yevhen, and I'm working as an architect in one of the biggest retailers in the world, architect of IT systems, because my company is not an IT company. We are a retail company, and I'm just doing IT stuff for a retail company. So this is my first job as an architect. Before that, I was a developer. And in this video, I want to discuss this transition from a developer to an architect and what to expect from the architect job if you were a developer all this time. Because right now there is a lot of conversations about that developers are dying kind, that no longer the world will need developers, unfortunately, and many developers start thinking of their future and where they can transition. And for many, uh, the natural solution would be growing into an architect. But I need to prepare you that the work of an architect is not exactly what developers can expect, because development is a really technical job. Yes, so you code, you integrate, you connect to other systems. Well, architect can do all of this stuff as well. At work, I mostly do like integrations and like connect and align, reconcile systems between each other. But at the same time, architect is not solely technical work. This job implies a lot of thinking, a lot of contemplations, actually. So you need because for developer it's really easy. You get a feature, like you get a ticket. It's a description of a bug or description of a feature. You have a clear uh, destination where to go and what you need to do to accomplish your task. It's very much aligned with the human way of thinking. We think really in a simple way. We need a certain task, like some concrete job to do, and we don't think about all different probabilities, what can go wrong, what can happen. We don't think about unknown. Yes, there is some special concept in cognitive psychology or philosophy, unknown. So as humans, we don't like to think about something that may happen or may not happen. We just think about in very, very specific terms what has to be done, certain task, certain job to be done. And this is all about the work of the developer. You get a description like functional requirements, like certain requirements, you do the job. But this approach doesn't work for an architect. As an architect, you need to think about the whole system and the design of whole system, and you need to think about unknown. Unfortunately, yes, it's really uncomfortable because it's unnatural to our human psychology, to the way we think and act. It's very unnatural. But an architect must think about risks, about design, about possibilities, about what may go wrong, about expectation and how it can actually work out, like in the end in production. Uh, but it's only talking. Yes, I also in this video I also want to show you some examples. It will be a very basic example because I am not in the position to share my complex systems at work, and I don't have my own complex system. What a surprise. Yeah, so that's why I created some very simple example. So this is a specification document that I have written. It speaks about retail enterprise order management system, or OMS architecture. So based on, we will speak about the order management system in the terms of architecture. with architectural thinking. And then we will also review some really basic code example that I've created with AI, because yes, AI is here. We no longer write, as an architect, I sometimes write code, but it's under 20% of my job responsibilities. And even when I write code, I mostly outsource this task to AI, and then I just check, run some tests, and sometimes do some corrections, but I don't write code a lot as an architect. So this is a huge difference between developers work and architect work. So architect is more about thinking and designing, and developing is about fun. Yeah, keyboard, coding something and see the result on the screen. So in architecture of the system, we always need to think about functional requirements, that's what the system is able to achieve. Yeah. So if we're speaking about OMS, it will be something like accept orders from multiple channels, from website, mobile app, point of sales in stores, marketplaces like Amazon, eBay, validate payments and reserve inventory. So we will validate payments with the help of a payment provider. We will reserve inventory with the help of inventory management system, or ERP module for inventory management system. We will speak about ERP later. And a bunch of other functions, yeah, including analytics dashboards, orchestrating processes, and so on. So we, first of all, we define functional requirements, what we expect from the system, what it is able to achieve. This is like the foundation, the start, everything starts from here. Then the very important part is connection with the system. Yes, connection. There are two main types of connections. For example, it can be direct API connectivity. Yes, so you just call API of another system. It's all driven by this consecutive logic. One thing after another. It's really like we human like to think. Yes, about finish one step, the next step. So, and the systems call each other through API, which is very simple setup. And another major type of this connectivity will be it's publishing events through event brokers. For example, there is like Google Pops publisher subscriptions, yes, service. It's a middleware, a broker that will manage events across the system. So, for example, one system triggers an event, other systems are subscribed to this event through a broker infrastructure, and then they react to an event in a certain way. Yes, it's a little bit more complex system with a little bit more synchronization, but it's very functional. Yes, if it is set up properly. Then we also do everything in architectural style, but it's a long talk, to be honest, about architectural style. So I'll skip this one. We design flows for every functionality that we want to create. We design flows, including exceptions, Debian flows. It's a lot of thinking about what may happen, not only what we expect to happen, but about what may happen. Here is just an example of very simple flow. Order flow, order created, payment pending, paid, order allocated to a warehouse, order is picked, the preparation is started for the order, preparation in progress, prepared, packed, label for delivery, yes, stage, like the final status before delivery, shipped, given to like a shipment service like FedEx, for example, delivered, closed, yes. So we design multiple flows for all business processes. And then we write a lot of documentation for every flow. Then yes, we're thinking about failures to flows. And the biggest part for an architect is how we set up and test and guarantee the proper communication between systems. For example, for order management system, we can communicate to 10 to 15 different systems. Now, I mean, that's too much, maybe 3 to 10 different systems. Here are some of the most common example. It will be inventory management system. Sometimes it's not a separate system, it's inventory unit or module for ERP system. ERP is enterprise resource planning system. It's mostly for, controlling and auditing all the resources of an enterprise. And then it's a payment service, of course, a warehouse management system. Yes, everything about preparation and delivery, ship and delivery service. It will be third party mostly for retail companies. Then customer relationship management systems or CRM, uh, PIM, product information management system, business intelligence application like BI and for Microsoft. Every big company has its own business intelligence cloud application to market to other businesses. Then enterprise resource planning system, it's ERP, what I have already mentioned. Tax engine system, it's also like in 99.9% of the times it will be third party, yes, some specialized service that we lease, that we have subscription with or membership with. Yes, it's just business model of cooperation with them. Then fraud detection system, sometimes it can be, integrated functionality into other systems, yeah, most of the time, but sometimes it can be some separate development. So that's we connect and we test connectivity with other system all the time, and this is where most of the time things go wrong. Yes, in connection with other systems. And for the data architecture, the main points, it's to have a database, yes, for every system, or we sometimes we can use a shared database for multiple systems, but we normally think in the terms of the data optimization and data security. Yes, depending on what control, what level of control we can exercise over every systems that we use in our architecture. Yes. Security layers and security, it's another big topic. We can speak about this for hours. And availability, it's about, trying to reconnect if something doesn't work, and trying to reach out to the system again, or to play a flow again. And here just I added one example of an advanced feature, because everything of this was pretty basic, for order management system. But an example of an advanced feature will be smart routing. For example, if we have a big company with multiple warehouses across a country or many countries, then we can kind of navigate routing and logistics with smart real-time decisions, and to pick warehouses, to pick shipping services, and optimize cost and time. Yes, so let's jump onto some practical example. So I have created this simple app with Claude Code with AI solution. Just to continue our conversation about architecture, it's written with the simplest technology, just Node.js, JavaScript, nothing complicated. I have a local host server. I will start it, npm start. Okay, I believe I started the local server, but it hasn't opened the website for me automatically. But I can go here now. So it's a simple dashboard of order management system, and the functionality is pretty basic, but let's review it. We can create a new order. We can choose a customer when creating an order. Normally, with the order management system, we create a new customer with an order. Yes, when a new customer makes an order, we create her profile in the database of order management system, and normally it is the website, the storefront, yes, of our business. delivers this data to us, but it also can be a connection between CRM, customer relationship management system, website, and order management system. Yes, and normally we try to synchronize the data for one entity, in this case for one customer, between all of these systems. So to synchronize, we use depending on how we exchange data between the systems. So we can use just REST API to give a web call, the call through the network, through the internet, using HTTP protocol and calling REST API, application programming interface of a different system, and we post new information or we synchronize new information. So, or it can be event driven. For example, creating a new customer in order management system can trigger an event, yes, and customer relationship management system will react to this event by creating a new customer, in itself. So it might not be the most natural flow, just off top of my head, but I just want to show you two main ways how we, move information between systems. So let's say we're creating a customer, we pick up a product, we have PIM, product information management system, to pull data from it. Its data, this system is specialized in product information, so we can pull data from there into our order management system. And we can feed the next system in the flow with this data. It will be probably warehouse management system. All right, and then we can. I'm using this dashboard, but it's not how it happens in real life. In real life, it's mostly posted, yes, with a web service call, and then it's already posted. I'm just kind of doing it to simulate for the purpose of discussion and conversation. So it will be Alice Johnson. All right, and she will be at Madison Avenue at Busy Place, New York. Oh, something wrong with my capitalization skills. Okay, and then like this. Okay, and we can post the order right now. So again, we're speaking about OMS, order management system. There are dashboards, and there is back office that we can use for some administration tasks. Yes. So we have order creator and we have status. Status is very important because it's normally aligned, synchronized between all the systems. And normally the system that is driving the updates will be a warehouse management system, because it's most of the order statuses are changed from just received, allocated, to picked, preparation and progress, packed, already in a package, ready to go, and then also stage, like prepared for delivery, and then shipped, sent to delivery service, and then delivered. So warehouse WMS will be a driver for status change, but order management system will be the system that receives this status change and updates other systems like website, CRM, ERP, and also order management system will communicate with the payment provider to to validate that the payment has been authorized and captured. Yes, same goes for returns, for return statuses. What else we can see here? So we have inventory, so we will connect to the inventory unit of ERP or inventory management system, depending on what we use, and we will display inventory information. By the way, order management system will need to call inventory system to validate that the inventory is sufficient, it's available, and then after the validation and placing the order, we will reserve that inventory in inventory management system. So it's also important for an architect to think about the sequence of events, and to think about what's the most practical and logical way to build the flow. For example, probably first thing we need to do is to validate shipping and billing addresses. Yes, because they're wrong. If they're wrong, we cannot proceed with the. We should not even try to place the order. This validation should happen in the website storefront, and then after that, when a user tries to place an order, then we need to check if the payment is authorized, and then we need to check if the inventory is sufficient, and only after that we should post the order in OMS and return respond to the website with the confirmation that the order was placed. Yes, so the sequence of events, and it just all everything that I'm talking is just very, very simplified. Yes, so for every of these events, you need to think all the possible scenario. You literally sit and think, okay, what else can happen? What? Okay, yeah, so it's all about quality design. It's dramatically different with what with developers mindset, because they get a task ticket, they see what has to be done, they see specification requirements, and they just do it's really comfortable. Yes, and it's also fun to code. It's not so fun to architect. Yes, you need to think about all the possibilities, and you need to kind of fight with the nature, with your nature of thinking of what you don't want to think of. Yes, where warehouse for order management system, it can be orchestrating app, and we may have many warehouses in the country. For example, East Coast Hub somewhere in New York, West Coast Hub somewhere in LA, and Central Fulfillment, I don't know, Texas, Kansas. And then we will order management system based on the geographical information submitted from the storefront system. It needs to decide which fulfillment, where the fulfillment order will be created. Um, in which of these warehouses. Yes, it's also about orchestration and orchestration flows. Yes. Uh, Customers, we normally in order management system, we will need to keep all the records. For example, why do we need customers in order management system when we have CRM? Well, we need them because we want to pull their information and deliver to warehouse management system, so they can create a proper label. So then USPS or FedEx will get the customer's name. Yeah, so we need to keep all the records and keep them synchronized. But we don't have to store all customer information here. CRM is good enough for that, yes, but we can store the basic customer email, name, location, yes. Then normally in every system, we prefer to have analytical dashboard, but it also depends on how developed your system is. It might be just a microservice that's doing some certain task, some certain business function, and just, works kind of in isolation from the big data of your enterprise. But if you speak about order management system, analytics is a must, because we expect to see order information here. So we want order insights. Yes, customer activity, purchases, insights. Event log. Yes, if you're speaking about event-driven architecture, which is a very common, yes, in complex architectural solutions, we want to be able to track events that trigger changes in other systems. Yes, and webhooks. Webhooks, again, speaking about event-driven architecture, yes, webhook will be something like a section of code, a section of the system that will be processing external system calls, external system delivery. So think about warehouse management system, and when something happens there, for example, order was shipped. Yes, it's an event, important event, and this event should update order management system. So it will call OMS API, yes, probably through REST API, and it will then REST API will receive the call and a webhook will be triggered. Yes, some certain functional element, functional part of our system that is kind of like specialized in processing some external calls, external system calls. Yes, so normally we need to design a lot of webhooks for every system that communicate with other systems. Yes, it's a very natural architecture solution or common. So what else we can dig from this example? Also, yeah, I mentioned many times API, REST API, but we also have this batch architecture style. When when we want to process data in batches, or batches, and not one call at a time. Yeah, so sometimes for that we need a SOAP API, so we can deliver data in XML files, in big quantity of data. So I think that's it. I hope my examples were interesting for you, and you got an idea how what the architect work is about. It's all very, very high level, but architect work is so complex that if I created this video in details, I mean it would be officially the worst video ever created. Because if I try to speak about all this in details, it's collapse. But I hope on high level I gave you an idea what the architecture is about, architect work is about. And please follow me, and look into my career insights. And thank you for watching me. Yeah, have a great day. Bye bye.